on sum, difference, and double angle identities from the textbook, section 6.2 in Pre-Calculus 30, the McGraw-Hill Ryerson Pre-Calculus 12 textbook. And we're looking at page 299 here. So sum, difference, and double angle identities. We just got finished talking about in 6.1, Pythagorean identities, reciprocal identities, quotient identities. So what we're saying is that there are certain relationships that are true all the time, no matter what. So I'm just going to go back before we hit these notes here, that these were the quotient identities. So if you have a tan of any angle, you can express that value as sine of the same angle divided by cos of the same angle, okay? So these are identities that are true all the time for any permissible values of the variable. Here's the Pythagorean identities. We even found out that we can rearrange these identities to form other identities. They're always true all the time, okay? And of course, the reciprocal identities. So if we take a look at 6.2, what we're looking at is sum and difference identities. And of course, sum means adding, and difference means subtracting. So the point here that we're going to explore today is that trig identities can be expressed using related angle measures. And I'm going to talk about related angle measures first. I'm going to talk about sums. So if I take a look at 90, that is the same as 60 plus 30. Okay? If we're counting, if we're just talking straight basic algebra, that's always true, right? 60 plus 30 is 90. So what we're going to do is we're going to explore the relationships when it comes to sine and cos and tan and that sort of thing, the relationships between sine of 90 in this case, and then sine and cos of 60 and 30. And what I want to develop for you is that because geometrically they're related, okay, so here's a 30, 60, 90 triangle, and we know that there are ratios no matter what size the triangle is. So that means that these three angles are related by these ratios here all the time. So that's a good launching point for finding some kind of pattern that's true all the time that relates them. So let's just do some exploration. Please get your calculator out. What is the sine of 90? You may remember the unit circle, which I have up here. And the sine of 90 degrees is right here. And do you remember which one of these is the sine of 90? The first one or the second one? Which one is it? It's the second one, right? It goes cos sine. So you didn't even need your calculator for that one, but the sine of 90 is 1. Okay? We see that. Everyone kind of gets that. What's the sine of 60? We could go to the unit circle as well, or we could go to the special angle triangle like I have in the notes here. So I have this written down, so we may as well just use this for all of these. The sine of 60 is opposite over hypotenuse. Root 3 over 2, agreed? What's the cos of 60 then? That's adjacent over hypotenuse, that is 1/2. The sine of 30, okay, start from 30, that's opposite over hypotenuse, 1/2. And the cosine of 30, that's adjacent over hypotenuse, root 3 over 2. Okay. Now, right away, you're kind of saying, well, Mr. Maxwell, I'm not really sure how these numbers are all related, other than maybe there's a 1/2 plus a 1/2 equals 1 there. You know, you kind of maybe see that, but then it's like, I don't know if I can draw any conclusions just looking at that. And I wouldn't expect you to. There is a little activity that we're not going to do in this class here today, but there's a little activity. It's an investigation, and they talk about this diagram right here. They kind of go through it, and they give you some values here, and they're asking you to kind of explore the relationships between, alpha angle and beta angle, and of course the right triangles that exist, and to see if you can find any relationship. So we're not going to do this activity, but this type of activity is something that you might want to try, and I'll just point you to page 299 in the textbook, that it might be a good idea for you to work through this activity if what I'm telling you really is too abstract for you, or just there's no connection. So this is something we're not going to take the time to do in class, but I would suggest that maybe this is something to look at to further deepen your understanding. Okay, but if we look at this again, there are there is an arrangement that we could, that I could show you that is certainly true for this circumstance for 90, and in terms of 60 and 30. But like I say, it's kind of out there. But what I'm going to show you is this. Okay. So if we had sine of 90, which we know is 1, what would that equal in terms of sine and cos of 60 and 30? So we're going to involve all of these. Okay? Now, I don't know if you've looked at the textbook already and saw the arrangement, but there is a relationship between this right here and between all of these right here. And it's not 1/2 plus 1/2 equals 1 because we haven't involved this at all. So if you look on page 300 in your textbook, you might be able to come up with a way that we could arrange all of these so that that one side equals the other side. And I'm going to just throw this up here right now. 1 is on this side. And how can we arrange these other numbers to make these equal to 1? Add them, subtract them, multiply them, square them, root them, whatever. So I'm going to point you now to 300, and I'm going to get you to look at that. So here's page 300 coming up. I guess that was 300, right? Where are we? Oh, right here. Okay. So on this page somewhere, it gives you a clue. Can anyone take a look at these identities that are already given in the textbook and to show me, say, hey, Mr. Maxwell, I know what we could do with all those values that connect with these identities. Does anyone see the identity that we might want to use here on this page? Anybody? Yeah? Sorry? Sine A plus B. Okay. So you're saying this one right here. Let me just clip that out here for us. Okay? See if I can just grab that one. Okay? Good. So we are looking at, see if I can plunk that right there. So this is the identity you said, hey, this one looks like I could use this to put all these numbers together. And I would agree, actually, because 90, we already said, was actually 60 plus 30. Okay? So this identity says that if you can split up this value here, and in our case it's 90, if you can split it up into, say, 60 plus 30, then that means that there is an expression that exists that you could write this value in terms of sine and cos of the added values. So 90 is actually 60 plus 30. So let me rewrite this. 60 plus 30. So that means that I should have the sine of 60 here, because here's A, right? 60 is A. So sine of A, and I'm going to multiply by cos of B. Oops, 60. Cos of 30. And then I'm going to add the cos of 60 times the sine of 30. That's what this says right here. Now, we know this is an identity because it's given in the textbook, and we didn't go through the investigation to kind of explore this. But this is one possible way that we could show that there's a relationship. So let's just test it out. Okay, clean some of this up here now. Use a different color. So what is sine of 60? Well, that's root 3 over 2. What's the cos of 30? Where is that? Over here. Oh, that's root 3 over 2. And then we're going to add, what's the cos of 60? 1/2. The sine of 30 is also 1/2. Okay. All right, so what we have here, when we multiply these, we get 3 over 4. And when we multiply these over here, we get 1 over 4. So 3 over 4 plus 1 over 4 is 1. And we already said that sine of 90 is 1. So this little relationship right now is confirmed in this one example. Okay? And again, we could be here for a long, long time, kind of trying different things and geometrically sort of going through activities to kind of see what the relationships are. My big thing is this, is that there are already some clearly established truths in math that are called identities, and I'm just going to kind of start to bring these, because there's a lot of them, okay? And so I'm not going to go through the derivation so much, but I'm just going to tell you that there are some, pardon the pun, some and difference identities. And I'm just going to get back to the text here and show you those, okay? So I want you to write all of these down, okay? So just take a moment, jot these down into your notes. We'll talk about this. All right, so if you take a moment to evaluate this on your calculator, let's say we're taking COSA of something random 57, and we're going to use this to see if it's verified with this random situation. So it looks like I could split 57 up a whole bunch of different ways, right? So I chose 50 and 7. And so if we put 50 in for A and then 7 in for B, we get something like this. Now we've both evaluated these in our calculator, and it looks like I got something that was very, very similar. Of course, I rounded my decimals, so it's not going to be exact same, but it's pretty much, this is close enough to say that that's confirmed, right, to the millionth or billionth place, whatever we're the same. So did you get the same thing, or did you get something really, really wacko? Who got the same on both sides, right side, left side? Okay, that's good. Okay, so we should do another test for the tan. So why don't we do that as well? Use different numbers that I used. I used 50 and 7. I want you to use something else. Do 40 and 17, or do 55 and 2, or do whatever. You can even try negative values if you want. I don't know. Somebody may want to try that. Okay. But I want you to pick two different numbers that add up to 57, and I want you to fill this in, and let's have 15 or 20 different confirmations of this tan identity. So go ahead and do that. All right, so I did 39 and 18. You were supposed to do another set of numbers. Okay, I got the same. Did anyone else, after evaluating this, and yes, I do want you to show this for your notes. You can look back and see how this works. Did anyone else get an identical or very, very close number like I did over here? Okay. Did anybody get something very different and you double-checked it and it turned out to be, you didn't make an error? No? So which numbers did you guys choose? I chose 39 and 18. Which numbers did you chose? So you did 57 and 0, okay, and you put them in here and that worked. Okay, what numbers did you choose? 50 and 7, okay. What about you? What numbers did you choose? Yeah. Okay, you did. Okay, so you did a negative. Did it work out with the negative? So you did 60 and negative. Did anybody else do a negative? Try a negative number? Yes? Okay, so which negative numbers did you do? 69 and negative 12. Okay, so did it work out? Did all the values worked out? All the negative signs worked out and everything? Okay, you did too? Yes. You tried negative? Okay, and it worked out? Okay. So for an identity being A and B, I guess we would think that it should work out for any angle A and any angle B that add up, right? Positive or negative, right? Even decimals or whatever. Now, you're going to be limited by your precision, okay, for your calculations. If you have a decimal, you're going to have to be rounding numbers, so that's why these won't be identical. You see it, 0.8986 here, 9855, and so on. So it's going to be a little bit different, but it should be pretty close to be the same. Okay, you put 90. All right, so you tried 90 and negative 33 or whatever. Okay, so why did that not work? Why is this not okay? Let's see, 10, 90, plus negative 33. Because tan of 90 is undefined. That's why. So when you fill this out, and you put tan of 90 right here, this value, which in my case was this would have been undefined, so you can't use that one. So remember, these identities are true only for permissible values of the variables, right? We established that in 6.1. Only the ones that are permissible can you actually use in these to verify these identities. Okay? All right, so these are the sum identities. Very similarly, these are the negative identities. So let's take a look over here in the textbook. Sorry, not negative, the sum, the difference identities. Okay? So here's the difference identities. We'll pull these over to our notebook, and we'll take a look at these as well. So do you see some similarities and some differences here between the sum and the difference? Similar. I heard back there, they're the exact same thing, except opposite signs. So let's take a look and see if that's true. If we have, here's our sum one that we just did already. So this was plus is plus, and plus here for cos is minus. So does that, for sine it's minus, and for cos it's, if you subtract here, then you're adding here. So I guess what you'd want to say, instead of everything is just opposite, okay, what you want to say is that if this is a sum, for sine, this is also a sum, okay? So sine is sum, SSS, sine, sum, okay? Cos is opposite. So cos is opposite, right? So you might want to think about something like that, right? And yes, you should try and memorize these. I realize that I'm giving you a cue card for your exam. You may write these things down. You could probably get by in life without memorizing these, but you should do your best to try and memorize these. For some difference here, it's sine cos, cos sine. That is not hard. That's the same for sum and difference. You just have to remember the signs. So yeah, if it's minus here for sine, it's minus. So this is the same. Same sign here and opposite sign for cos. And then for tan, of course, negative, we have a negative here. So that's the same sign up top always. And then the opposite sign on the bottom. So yes, they are very, very similar, and we won't test the negatives like we did the positives, but you can probably understand that we could do the same thing in these things. Questions? Okay, so the last part of this section, this is sum, difference, and double angle identities. So there are also some identities that relate an angle, so an angle A with its double angle. Okay, so 2 times that angle. So what's important to note here, and a lot of students get this mixed up actually, you have to be real careful. 2A versus A. So if we're talking about sine of 2A equals this in terms of A, well, this value is going to be half of what this value is, right? So if 2A is 80, A is what? 40, right? Because 2 times what gives you 80, right? So if we're talking 100, then we're talking 50. So if we're talking sine of 60, let's say, the double angle identity would use what angle in here? Yeah. So if this is 2A, this has to be 1A. So if this is 2 times something, the something would be 30. Okay? So you have to be real careful about that. Some people automatically say, hey, double angle identity, so I'm going to put 120 in there because it's double angle identity. Well, no, this is the double angle. This would be the single angle, okay, or half of the angle. So it's always in terms of 2A on this side. So let's just really quickly just verify this with 60 and 50. So sine of 60 is what? Let's go back to our unit circle. Sine of 60 is this one, right? It's cos and sine. So root 3 over 2. All right. So that means that root 3 over 2 should equal 2 times sine of 30, which here's 30. Sine of 30 is 1/2. Sine of 30 is 1/2, and cos of 30 is 3 over 2. So let's just see if this works. If you evaluate this, that 2 times the 1/2, that goes away, and what are you left with? 1 times root 3 over 2. So it is confirmed, or verified at least, with this pair. All right, let's take a look at tan A over, or tan of 2A over here. And let's, again, do an exercise like we did before. I'm going to each of you to pick an angle, and then write it in terms of the half of the angle there, and just test to make sure that this is true, okay? So you are choosing an angle, and then you're putting half of that angle right here. Or choose an angle and put it here, and put the double angle there. Verify both sides, okay? So just take a moment just to do that on your own.